So that is a bit about our panel this afternoon. Someone who comes from Festo Didactic SE, and together with us as well is the Didactic Manager from Malaysia, Mr. Ng Swee Min. He will also be part of the co-panel, so to speak, if there are any concerns or any thoughts or any questions to be answered from the Malaysian perspective, right? Okay, so the topic for today would be upgrading specific technical competencies for industry changes due to the Industry 4.0. So again, a recap of the whole digital TVET digital revolution is to get our educators ready so that they can be better lecturers and preparing their students for what's happening out there as far as the Industry 4.0 is concerned. Without further ado, Mr. Schmid, I hand over the floor to you.
Wonderful. Thank you so much for the perfect and professional introduction. So let's get started. There's a lot of topics, and I'm also willing to share the slides with you. So there is no need to make a lot of notes. There's no need to make screen captures. You will get the slides distributed. How we are going to make this will be handled at a later stage, but I'm happy to announce the slides. Please also call me Volker if you have any questions in the break or at the end. As I said earlier, you can also post questions in the chat. Maybe my colleague Swimin is already able to answer those questions in the chat to make it a bit more easier. But let's see how it goes. As it was being introduced, the topic of today is upgrading specific technical competencies for industry changes due to Industry 4.0. It may not only be based on Industry 4.0, or we have a lot of other interruptions, or we have going green, we have renewable or energy toppings, we have circular economy, you name it. So there are a lot of interruptions in terms of also the educational side of the career. I will not tap on all those topics because that will exceed 45 minutes, respectively 1 hour. So I will highlight a few things, mainly also towards the second part of the presentation. But let me first of all start giving a little bit of an overview, also by some guiding questions. I mean, for example, how digitalization is changing enterprises and business models. I think here we also need a strong support, in particular for medium-sized companies. And then, of course, why the industry should also take care about Industry 4.0. And last but not least is more or less the topic of today. How do we foster the future skills and competencies in order to tackle, we can also say to tackle the skills shortage which is prevailing. Now, the good thing is when we talk about Malaysia, we can also look into neighboring countries. No country is ahead and no country is behind. Industry 4.0, yes, is a term which is more or less 10 years old or 9, 10 years old, but Industry 4.0 will still continue for another, I don't know, 2, 3 decades, whatever. Maybe Industry 5.0 will be coming, whoever knows that. But the good thing is, the industry is not far ahead in terms of mapping industry and education. So therefore, we have a good chance within the upcoming years to still fine-tune the educational models in order to provide the right skill sets that are currently required and also future ready. The agenda for today, I don't go into details. You will anyway get the slides later on. Let me quickly go a little bit into where we are coming from. Yesterday morning, Swimin and another colleague, Fu, made a presentation. So here a few things are covered already, so I do not need to go into details. But it's important to understand what is Festo doing, because I would say we are one of the only companies who are really having an ecosystem inside the industry and inside education. So on the left-hand side, Festo, the industrial automation group, we are around 21,000 people at the moment. We are present in 62 countries in the world. Malaysia is one of our subsidiaries. We are still family owned, and interestingly, around 8.5% of our total revenues are reinvested into research, but also into further training of existing employees and also investment into future employees. Future employees, that means either coming out of our own dual vocational training, or we also have models which are the so-called dual university models. On the right-hand side, Festo Didactic, we are one of the leaders, if not the technical leader or the market leader in technical education systems. I think very important or very impressive is the number of having 46,000 laboratory installations worldwide. I don't know, even maybe Swimin may not know, but I think we have hundreds of laboratory installations in Malaysia as well. Schools, but also certain in the private sector. I mean, one famous German company, for example, B. Braun in Penang, is also one of the companies who are involved in the Malaysian dual vocational training systems, also supported by the German Chamber of Commerce. We have Infineon also contributing, just to name two, in this case, German companies, but yeah, there are others who are contributing as well. So, as I mentioned already, Festo and Festo Didactic is more or less the same company. We are just having two different names. One is Festo Automation, the other one is Festo Didactic, but we are all under the umbrella of the Festo group. And for us, actually, it is very important to always bridge the gap between automation, the industry side, and education. And luckily, on a daily basis, we have more than 5,000 people who are in daily touch with the industry. And this is where we are getting our information from. What is required at the moment in terms of technologies? What is required in terms of technologies in the next 5 years? And this is, or the specific information regarding this allows us to influence our solutions, our training solutions, our digital solutions to map and match. That means if we know that there's a major technology coming into the industry in 3 to 5 years, we can start to prepare the students today. So once they are graduate, once they are ready, they can fit nicely into the industrial landscape of needs and requirements. We are also active when you look into the into the educational landscape. Of course, we are also involved in STEM, secondary schools. We do a lot in TVET, T and VET. I think we have to be very precise. TVET is training and vocational education and training. So T is the training part that we do, continuous training, upgrading of skills. And VET would then be, of course, the vocational education and training. We do a lot with university as well, also in Malaysia. Yes, we are also looking into research, but I would not highlight the research part. I would rather look into the preparation of the students and providing a good development of the skills and knowledge, which is the basis for a later research topic. But without having a good basis, research might be a bit challenging. And of course, we are doing a lot with the industry. I mean, I just talked about B. Braun. I mentioned Infineon. We have in the southern part ST Microelectronics, for example, in Malaysia. So here we are doing a lot of industrial workforce development. That means we are training people from the industry, short-term courses, long-term courses, whatever is required. And this gives us the entire overview where we are actually active within the industry areas. And here is already a bit of an outlook what is coming in the second part of the presentation. I mean, yes, we believe that skilled people shape our future. And at the moment, we talk about Industry 4.0 affecting actually everything. I mean, it's starting from the VET, vocational education level. It's affecting also university level, but it's also affecting the topic of lifelong learning. I mean, nowadays, once you are becoming an employee of a company, learning doesn't stop. I mean, also, Festo internally, we are attending further trainings twice a year, at least 3 times a year. So here is just a short overview what is coming a bit later, once again, when we talk about specific trades like automation, maintenance, mechatronics, and so on. As I mentioned, well, Festo is very active in industry, and literally we are active in all different kind of industry applications, whether it's automotive, whether it's chemical, whether it's electric light assembly, food and beverage, you name it. Festo is there, and this is actually where our information is coming for the competencies for tomorrow's companies and employees. And since we want to make our partners and customers successful, we are the ones who are driving the automation part of them. And that's why one of our claims is that, yeah, we are the engineers of productivity. And in the end, Industry 4.0 is also looking a lot into productivity. This is mainly where it is based and also coming from. Good. Once again, coming back to those guiding questions, and the headline now is a bit different, is how do we manage the complexity of Industry 4.0 new technologies? And let me start with one picture, and you can look into this a bit. I will quickly have some water and good. What you see on the picture is actually Festo's own company. That's our own ecosystem. We have already an Industry 4.0 ready manufacturing plant in Germany. So what you see here, most likely in the middle, we have catchwords like ERP, MES, real-time data, we have digital twin, we have traceability, big data mining. We all do this. And of course, the big topic when it comes to Industry 4.0 is also, we talk a lot about vertical integration, we talk about horizontal integration. Literally, we are talking the whole eco and supply chain topic from raw material, from suppliers, all the way until the customer and end user. So this is actually the horizontal line we are following. Industry 4.0, Industry 3.0 was mainly focusing on the manufacturing part of it. Now Industry 4.0 is coming a lot more with IT, but also with connectivity. At the same time, we as consumers, we are demanding specific topics. If you look at the car, for example, I always make this example from the small Audi A3. Excuse me. The Audi A3 seems to be a mass product, but it's actually not. We have an opportunity to configure this car as we want it, and there are 30,000 options. I want to have a green car with a diesel engine and leather seats and this and red seats and whatsoever. So this is the complexity of manufacturing today. Initially, it seems that it's a mass product, but it's actually not, because the customization part is so demanding that the manufacturing part has to answer this. And luckily, with the new technologies like RFID, we can do it. And as I said, also, I mean, suppliers are connected real time to manufacturing plants. So this works. What does not work is, and now here are coming a few hurdles. In the middle part, for example, you see ERP or MES. I can also use the picture on the next slide, which is a bit more simple. But for example, a company wants to go more digital. And then the discussion is coming up, okay, what software tools do we maybe need for our production? For example, do we need MES, manufacturing execution system, or do we need an ERP, an electronic resource planning tool? Or do we need PLM tools, that is product lifecycle management? So to make it short, it is very, very complex to make the right decisions. And if you make a wrong decisions, productivity will be worse than before. The same is applicable to, going back to this picture. It is not possible to run any production facility at the moment with just one IT tool. Festo in our Industry 4.0 ready manufacturing plant in Germany, we have roughly 40 to 45 IT tools in place to run it. So now imagine this complexity. We need to update 45 IT systems regularly. We need to have people who understand 45 IT tools at the same time. And this is applicable to all companies at the moment. The goal to go down maybe to 2 or 3 IT tools in the future is given, but it is not possible at the moment. And this also shows us how complex the whole topic is. And this gives us a lot of ideas also in which direction future skills and competencies are tending. Yes, there's a lot of IT on top now coming to, when you talk about mechatronics, for example. Yeah, when we stay within manufacturing, yes, we need a lot of those add-ons. We can also talk about a capability shift. This is coming when I talk a bit more about what we are doing internally. Keep this in mind, very complex. Wrong decisions may also lead to a less productive environment and may also then be more costly. So it is not so easy, and that's why a lot of future jobs will be also related to a good consulting approach to companies. Companies are in need of a wonderful hand-holding consulting approach to do the necessary steps to implement Industry 4.0. Yeah, coming quickly into the topic of education and TVET, the world has changed. Yes, we all know this. And COVID has shown us what is unfortunately a bad example, but we are not safe for the future years. So we need to tackle these changes, and also the business environment has to follow these changes. I'm not going into further details, but we all know that there's a talent shortage across the world. TVET in particular, also VET, may not always be the first choice of students. However, in this level, I mean, normally the VET TVET level is normally the backbone of the society, and when we talk about a GDP generation of a country, Germany is extreme dependent on the TVET level. This is mainly the small and medium-sized enterprises. Those are the taxpayers. Those are the majority of companies who employ the people. Those are the majority of companies who have also the most qualified people, because they need to be more flexible in terms or in comparison with large entities or large companies. But yeah, this is something which is prevailing globally. So I think we need to define better standards, domestic standards and also regional standards. We all know that also in Southeast Asia, there's always a movement of workers into Malaysia, out of Malaysia. The same is applicable for Thailand or Indonesia. So we need to find also an opportunity to have more regional skills, definition, skill standards. And that's influencing, of course, also the quality of the students and graduates. It's mainly happening in the TVET level. University level is a bit homogeneous, I would say already, but also here in the university level, we'll see a few more differences and yeah, not really regional and global standards yet. Yesterday I said, or I mentioned already, Fu and Swimin, my colleagues, have made a presentation, and they also talked about learning experience. Of course, what we also see now during the past 2 years, a lot of digital training has taken place, which is also not yet organized. I mean, here and there are good moves, but we need to also here ensure that the quality and is met and standards are given. We can also consider what you see towards the end of the slides here. Digital certification is upcoming. Micro certification is upcoming. In the end, also very important is digital training, yes, but we still need to have the so-called physical touch points. That means hands-on skill development is still, it has to be there. It cannot be replaced by digital. This does not work, and this does not provide the right skills which are heavily needed by the companies. So hands-on skills in any technical subject has to be still there. How this is being organized, even during a pandemic situation, is another situation and another discussion. Yeah, if you can ask me offline, or you can also ask him in. We are also working on this to have maybe roaming solutions for a community, and so on. Earlier, I talked about a capability shift at Festo. Festo is the automation part. And here, for example, when we look into the area of mainly the mechanical designers, when you look on the left, this is currently the job profile of our mechanical designers. There's a software developer part, there's electrical designer part, there's mechanical designer part. So in the next 3-4 years, it will mean that electrical is increasing. And this is also obvious. I mean, we see this also when we are going out now. I mean, a lot more electromobility is coming. A lot more electric vehicles are coming. When we look into a specific area like electric light assembly, like electronics industry, a lot of electrical applications are there, and this will constantly increase. So that's obvious. The amount of a pure software part will decrease. Also, the amount of mechanical is still there. Why? Because via this part, via the mechanical design, we have a lot of options to reduce energy consumption. I can share another presentation with you, or a brochure, that with the right approach, you can easily save 30, 40, 50% of energy consumption in production. So that's the reason why the mechanical part is still important. It's not outdated. It's not definitely, it's still very and highly relevant. Now, now very interesting is the middle part. We are not doing this shift based on recruiting or replacement. The main thing what we do here is reskilling and upskilling. So this will be almost up to 95%, between 90 and 95%, by means of short courses, by means of upskilling training programs. But this shows also a little bit the move regarding those job profiles. IT is always a part and remains a part. But important here is that still we believe that there's a lot of more options left when we talk about mechanics and mechanical. So that is how the capability shift will work at Festo. Now coming actually to the second part already. And this is the outlook regarding various competencies, what I just explained. So now the first part of the slides were, yes, that's Industry 4.0. Excuse me. That is, what is the demand? How can we tackle it? Learning experience is one thing, but of course still we need hands-on training. So now we are stepping into the part of the presentation where we are looking more into specific competencies that are currently upcoming. And I'm also convinced that they are prevailing at least the next 5 to 10 years. So one mega trend is digitalization. We know that, yes, this is something which is touching us on a daily basis. However, we are looking into 3 major parts of this. There is business transformation, there is social transformation, and there is technological transformation. A few things I have mentioned already. Of course, we have a lot of, when we look into the technical transformation, a few catchwords I have given already. We all still, every day we talk about augmented reality, virtual reality, digital twin. In the middle part, social transformation. There are, we talk about an aging society. We talk about demand driven. We talk about consumerization. I talked also about this because, consumerization is also a bit more the part of the influential part of what we want. Do we want to have customized shirts? We want to have customized shoes. We want to have customized cars. So that's also a part of the social transformation and business transformation on the left side. I think this is quite clear. No need to go into details regarding this. 1 second. Here's the slides. Of course, one mega trend is, and that's also the headline of today, this is Industry 4.0. The future goal of Industry 4.0 is definitely to have self-learning production systems. Partly, we can touch and do that already. For example, vision systems, together with artificial intelligence, are already self-learning, but the entire manufacturing processes are not, by far not ready to do a lot of so-called self-learning. So here we still have a long way to go. But when you look on the left-hand side in the box, then you see certain catchwords regarding competencies required and upcoming. There's a virtual product designer, integrated and automation and optimized production flow. So here we need specialists, flexible manufacturing, even down to lot size 1 is required, learning and self-optimization production. So a lot of things that actually already the complex picture of Festo has already explained what is upcoming. I go into this once more when we talk about some of the specific training needs and requirements. Again, we have the 3 top headlines, which is the business, the social, and the technological transformation. And then below, we have some of the key learning trends which are coming along. Virtual learning, that's of course what we do nowadays, also because of the pandemic. I already talked about, for example, micro and nano degrees when we talk about even digital certification. Lifelong learning is obvious. Blended, learn as you work. There's a lot of other catchwords like shadowing. We also have gamification. So this is also a bit partly connected to lifelong learning. Learning even when you work is not stopping. Then, of course, we have a lot of more artificial intelligence coming. T-shape profiles. I will go into T-shape job profiles next slides. And of course, learning platforms. We can also talk about experience platforms, which put the learner into the centric. So the future of learning is learner-centric. And this is what we can finally, by experience platforms, nicely do, but also supporting, of course, the teachers and the trainers. Let me see, we have already the first half an hour. You asked me to do a short break, but let's see where I can make the break. Let me finish the T-shape profiles, and then I do a short break if that is okay for you. So, yes. The T-shape is actually not so new. What is behind the T-shape? As you can see, it's actually just a T. Whether we go into the technical skills, whether we go into the creative skills, it doesn't matter. We can always define a so-called T-shaped profile for any direction. So there's base knowledge, there is business foundation, and there is business expertise. So the horizontal part of the T, that would be a little bit more the generalist knowledge. This would be the cross-sectional. I normally talk about a cross-sectional knowledge. And then when we go to the vertical part of the T, that would be the specialist knowledge. When we talk about, for example, mechatronics is in an educational program which is already in the market since around 20 years. Now, when we look into mechatronics, for example, and we want to create a T-shaped profiles, then we may add a few models which are coming closer to Industry 4.0. For example, an MES system. So we have the foundation is mechatronics, and then the expertise behind would be then an add-on regarding manufacturing execution systems. Another T-shaped profiles maybe in mechatronics is mechatronics energy efficiency. So we have always this opportunity to keep mechatronics as a base and add the so-called T-shaped profile based on either some needs, based either on some some market demands, but this is how we observe the current development. And the T-shaped profile may not stay. For example, mechatronics, MES might stay for 2 years. Then you are moving from this T-shaped profile to maybe a mechatronics, as I mentioned, energy efficiency T-shaped profile. So it's applicable to an individual, but it's also applicable to a group of students, or even to a training program. So this is what we mean when we talk about a so-called T-shaped job profiles. Good. As requested, I do now, after half an hour, short break.
Okay, thank you, Mr. Schmid. At the moment, there are no questions, so maybe I would like to ask one. Based on your presentation, you mentioned that the transformation, I think it's 2 slides before this, if you can go back, your talk about the 3 transformations, which are, this is the one, business transformation, the social transformation, and the technological transformation. So my question would be, are all the transformation happening at once, or do we plan for one before the other?
No, they are happening simultaneously.
Okay.
I mean, now, what can we take out? I mean, business transformation, new ways of working. Let's look into this. Because of the pandemic now, a lot of people do work from home office. It will not be gone, even the COVID pandemic will be gone. A lot of people will remain either work from home or have a little bit of a hybrid working model. It will be a big challenge, by the way, because a lot of office space will be suddenly empty. I know from some companies also in neighboring countries of Malaysia, big companies here, I mean, not here, but for example in Bangkok, there are big companies who are renting 5 stories or 5 levels of some office towers. They already canceled the rental contract for 3 levels because they exactly will continue with this model. Work from home, hybrid working, new work. So that is already coming. For the workers, I mean, also in my case at the moment, I have a 2-year-old son. So for me, it is idle because I can adopt flexible some working hours. I do not need to go 8 hours to the office any longer. Well, I'm not doing this anyway since 20 years, but that's exactly what is happening, and the pandemic has pushed this even further. Now, when we go into social transformation, whatever we take out of these boxes here, Generation Z. Actually, you can also talk about a Generation Zoomers. It's not only based on the Zoom tool, but when we talk about Generation Z, we can also talk about a Generation Zoom meetings, for example. It happened already. I mean, this is not something new. That's happening since also during the last 5 to 10 years. I mean, a lot of startups, a lot of IT-based companies, they are doing a lot more when it comes to virtual gatherings. It's not based on face-to-face meetings, and this will also, together with new ways of working, is happening already. Technological transformation, it's happening as well. I mean, machine learning. We also use this, for example, not machine learning, but using, for example, translation tools. When our board members speak in German, then the rest of the world is just catching up with the real-time translation into local languages to address our Japanese colleagues at the same time, to address our Vietnamese colleagues at the same time. So it's all happening at the same time, and it's also a bit interlinked to each other. I mean, business transformation definitely also has challenges when we talk about social transformation. Likewise, technology is disrupting certain transformational processes in this regard. So that was a long answer, but to keep it short again, Yes, it's definitely in parallel. It's happening already. It's nothing that is upcoming. It's started already, and we need to deal with it.
Okay, thank you so much. So, from what I understand, technological transformation would not boom if the business transformation and the social transformation is not there by its side, helping out. Would that be a correct assessment?
Yeah, that I would say it's supporting.
Supporting.
I mean, well, we can also talk a bit the other way around. When we look at a technological transformation, we have to ensure that we not lose the society, and that is then the social transformation. For example, my mother. My mother just turned 80. She's very good. She's smart, but now sooner or later, stepwise, she has a few challenges because everything is based on cards and PIN codes. You go to see the doctor, you need your medical card and you need a PIN. You go to the ATM, you need your card and your PIN. Okay, that is only an example, but technological transformation means we need to ensure that we are not leaving out parts of the society, and that's social transformation as well. Nowadays, yes, a lot is based on technological transformation. That is actually the dominating part. But how the society is reacting, or how the business and technological is more linked to each other, but we need to ensure that the social aspect remains intact, and we need to ensure that it is not a dividing development or a dividing transformation. We need to make sure that the parts still fit together. Okay. So
thank you so much. All right.
No issue.
So carry on with the presentation, Mr. Schmid.
Good. We are already in the second part. So just a few examples, what is upcoming and what is already happening. I mean, automation, for example, mechatronics. These skills are still required. I mean, we still need people who maintain a production environment. We still need people who plan, design, integrate machines in this environment. So therefore, these jobs will be still highly required. As I mentioned earlier, when I talk about a T-shape, or when I talk about, in particular for like mechatronics, yes, there is always an add-on, but the basic skills set of this trade remains, and it will remain still. I don't know how long. 2 decades, 3 decades. I can't give you the answer, but it is still very relevant, and it will remain very relevant because it's the very good firm footing as a start into Industry 4.0. And anyway, there is no pure educational program called Industry 4.0 at the moment, because you need part of a lot of basic programs that fit into this, and even data scientist, for example. Yes, it's a more pure IT based program, but you also need to understand, as a data scientist in manufacturing, you need to understand how manufacturing works. If it's not prevailing, if it's not given, then how to say, I don't have a slide for this, but I sometimes speak about an interesting wording, and it's like, if you digitalize a broken thing, you will end up having a digital broken thing. What does that mean? I'll give you an example from Festo as well. We have digitalized our assembly instructions for some components. When the digital assembly instruction is wrong, how can the poor employee down the line make a proper assembly if the instruction is wrong? So we, as a company, we should not underestimate first of all, the time and effort to digitalize such an assembly instruction. At the same time, whoever digitalizes such an assembly instruction has to understand the technical basics behind it. Otherwise, it doesn't fit. And this is a learning curve. This is a learning experience, which we also had to make. And then again, earlier I showed on the slides, we have an aging society. Within Festo, we have a lot of elderly people who are, and in Germany, the retirement age for a certain age group is 65 to 67. So when people are turning 55, 57, that means they still work another 10 years. So we also need to ensure that we support the aging workforce. Earlier, I make this example with my mom. She is also part of an aging society, but the aging workforce is also something that we need to keep in mind when we talk about those skill sets. It's not only the younger ones who you give them a tablet, they know what to do, but at the same time, the younger ones don't know how the machine is working. So that there is always a linkage between all those different traits. But yes, it's also a lifelong learning to achieve the full performance. And that's why we always mix on our shop floor level, we mix young people with elderly people. Elderly people have the experience. Young people are the ones who bring in new tools. And we love this combination. The younger ones learn what does it mean to have experience in manufacturing. The elderly ones learn how to use modern IT tools, for example, in production, like mobile maintenance based on a tablet. Example, I can talk about this a bit more. So coming stepwise a little bit to the end, just to make sure that we still have 10 minutes for discussion as well. Well, it's only a selection or what I mentioned already in the beginning. I mean, here we have industrial big data scientist. We have collaborative robot expert, IoT, OT integration manager, digital mentor, digital ethics officer, learn 4.0 engineer. So just an example. What is completely missing here? That would be another hour presentation. That is, for example, going green. Energy efficiency, energy saving. I talked earlier about energy efficiency design, reducing over-dimensioning. So a lot of interesting topics, which in my opinion can be easily stepwise integrated into a given educational program. The problem is with the educational programs is the time is always limited. I mean, for example, a standard dual vocational training can only last between 2.5 and 3 years. Now we have to ensure that we are not overloading such a training program with too many things, which in the end is also not shaping a certain competency. So that's always the big challenge by reforming an educational program. What has to be there? What can be omitted? And that again is a little bit a cross-sectional decision. How much do we need still when we talk about mechatronics, about mechanics, about electrics, about electronics and IT, and what is the add-on maybe regarding Industry 4.0? So that is something which is constantly being discussed. There are different models, but yeah, here is a selection how future jobs may be called. A lot in this overview, of course, is digital, but we should not forget the people, of course, also looking into the real manufacturing environment. Another thing whereby we have a good chance to support even the younger students is the so-called 4C competencies. I think it's quite clear. I mean, communication, collaboration, critical thinking, and creativity. If you ask me frankly, those people who are, and that's one of the points here, who are able to adopt the fastest are the ones who will, let me call it, survive. The same is applicable to companies. Those companies who are able to adopt quick and fast are the ones which will survive. I mean, we can look, for example, Nokia, we can look into Kodak, the company that had the films and the cameras. Now we can look still into the smartphone market and ask ourselves, where is BlackBerry? So there is a disruption happening in the market, and companies who are able to adopt are even growing. So this is how we can start early to make sure that the people are willing and open to adopt, and also flexible enough to adopt. So that can start in early childhood already. Creativity, curiosity, social, cultural awareness. So it has to start at an early stage, and then it will definitely influence also the ways we learn and adopt ourselves towards the end, at least, of our educational path before the career path starts. Good. Digital transformation and lifelong learning. I'm not going into all those details. On the right-hand side, you see a little bit of the competence mapping of a person working in the area of smart maintenance technician. So this is also something which is coming from us internally. In this job profile, creativity is not so dominant, but of course we need a very strong problem-solving technology. We need a strong understanding of mechatronic systems, of maintenance, and so on. Yeah. So for each of our own employees, we have this kind of profile, job profile, and based on this mapping also with a transformation, then we always know exactly which field has to be developed now, which competency field has to be developed within the next term. Term can be 6 months, term can be 12 months, depending also on our willingness to invest and to upgrade our existing facilities. Good. So now I saw roughly here and there we have some questions in the chat. Is that correct?
Okay, thank you. So now we'll have a look at the chat. One question from Dr. Umar. Can you give us tips on how a TVET instructor can nurture the 4 competencies among students? Yeah.
It depends a little bit, of course. TVET, VET program. I would need to have a few more details a little bit. I mean, how the teaching is happening at the moment?
Well, as far as the Malaysian Polytechnics are concerned, we have got a certain amount of time spent learning theoretical components. We have got a certain amount of hours spending on practical or hands-on component. Those are being done in the labs and workshops or computer labs, and the rest are being done in your normal classrooms.
Okay. No, I mean, of course, collaboration, if we start with collaboration, that might be a bit more easier. That's teamwork. So I think very important is that teamwork is happening. And then, of course, also rotation of teams. Because normally in the TVET level, it may not be so easy to have teamwork across so-called technologies. I mean, for example, during my study program, I was in the mechatronics automation engineering department, but we had to do teamwork with other departments, chemical department, for example, or business administration department, just to make sure that there is this teamwork coming up, this collaboration is coming up. If you stay only with technical people, then yes, there is a bit of teamwork, but you need people also sometimes from non-technical subjects to really foster these kind of also entrepreneurial thinking. and that's a bit of, yeah, one part is critical thinking, but it's interlinked, but this is happening when we go into the company, and that's how we can prepare the students before they enter the company, that a technical person has to talk to a non-technical person. Both are experts in their field, but sometimes the big problem is they don't understand each other. A non-technical person has to explain to a business person or IT and so on. So that is collaboration, but that also fosters communication. So an easy way to start with this is really to look into teamwork and then open up the boundaries of these teams. Technical, IT, business, whatever is available in the school. I can only give examples, but that would be nice then to think about it. There's a problem, and a team of students can work on it. Another option would be to foster also curiosity, creativity, but also something that is interesting is ask a neighboring company to explain a problem what they have, and let the students come up with some ideas. There was something that was a time. Oh, no, nothing? Okay, no. I mean, let a company come to the school, let them present quickly what they have as a problem, let the students start to discuss with this company. It doesn't have to be over weeks and months, but that's something which is, yes, the company has to invest a little bit of time, but this gives definitely a different aspect of the students, how to think about it, how to think about a solution, and then also do a critical thinking. Is it viable in reality? And that's a lot of this is actually coming out of simulation. And then the big question is it really viable? So this is another option that we can consider. Instead of doing internships with companies, ask the company to come into the schools, maybe daily problems, let the students think about it, and let the students think of a solution, let the students present it to the company, and at the end, the company maybe gives some small gifts, whatever.
Yeah.
Token. So this is also something which is fostering exactly this process of the 4C competencies.
Thank you.
Teachers might be also need to be involved. I talked a lot about cross-sectional, and I mean, we always talk about internships for students. I know a few institutions, also a university where I studied in Germany. Every 3 years, also the professors had to go back to do an internship. Just to make sure that the professors are really up to date regarding industry level standards, topics that happen at the moment, and that's also a real change. And actually, the same university, the Esslingen University, some of the courses are up to 80% are being taught by people from the industry. Part-time professors. Festo also has, if I'm not wrong, 15 mainly people from our research department, but 15 people are actually teaching at universities around as part-time lecturers, just to give up-to-date information to the students so that they know, okay, this is a real problem the industry is currently working on. So I think these real-time examples give more input to the courses and to the students as well. I think.
Thank you.
A few examples, I think, worth to try it out. Maybe Swimin, we can think of to do it with 1 or 2 schools to come up with an idea, and then I think we can do a test run and see the outcome. I'm happy to do that, Swimin, with you.
Yes, I think that's something that we can do. I think some polytechnics and also some institutions are also participating with Festo in their final year projects. I'm not sure which ones, but I've heard that some of the final year projects and also with Festo are doing, you know, some sort of collaboration and so on and so forth. So I think there's a lot of potential there. I agree with you, Mr. Schmid, that the participation of industries is what makes a difference between a TVET and a normal education. In normal education, the presence of the industries is almost nil. But in TVET, it does help a lot to have participation and collaboration with the industries. My next question is looking at the graphic that you have on your screen at the moment, Mr. Schmid. Is there any reason why creativity is right in the middle of the diagram, or is that just the way the graphic has been designed, or is there a purpose to it?
I don't know. I was not the one who designed the graphic.
Okay.
No. But well, my personal opinion is creativity, curiosity is something that should never stop. I'm always encouraging people, never stop asking questions, never stop asking, being curious. And this is also in the business environment. I want my colleagues to come to me with good questions, and also, yeah, we have to be continuously creative to remain in a certain position where we are. I think in the past, yes, we looked more into communication, collaboration, and critical thinking, but the part of creativity has been either willingly omitted or was not really in the central part. But looking at the changes at the moment, think of yourself in the pandemic. Talk to your teachers. Okay, suddenly work from home, homeschooling. We have to be creative to overcome this situation with, of course, certain obstacles, certain hurdles. But that is why creativity should never stop, and why creativity should definitely be part also in the learning, in the learning programs, in the curriculums.
Thank you. So I think, Mr. I've got lots more questions to ask. Actually, we'll probably do that on some other time because we have reached our 3:30 limit. Mr. Swin, do you have anything to add to this before we wrap up?
No, if you have more questions, you want to connect to Volker, you can always contact me. I think Dr. Umar have my contact, so we can link you up actually with Volker about this.
Yes. Okay, I'm very interested in the T model that he has.
Yep.
So lots of questions for me to ask. So we will see each other again in more webinars to come, I'm sure.
Sure.
Okay, ladies and gentlemen, thank you. That's all the time that we have. Thank you, Festo, for arranging this. Thank you, Mr. Smith, from all over, from Germany, to be part of our presentation. Your inputs have been very, very helpful to us. It's opened our eyes to see how we can plan ahead with our pedagogy, with the way we are teaching, the way we are organizing our TVET institutions. So with that, I would like to remind everyone as well as usual to fill in any forms and so on that has been posted up in the chat. I can see one there. There is one, so please have a look at it and also fill it in. And this being the last webinar series for this time around, I would like to take this opportunity to thank everyone in front of the TV screen, behind the TV screen, far, far away from where I am sitting, for their participation and for the sharing of their knowledge, and for coming down and being part of this webinar in the hope to make our students, all of us, and our lecturers ready and always being relevant for what is to come. As far as today, it's the Industry 4.0. Thank you so much. We'll be seeing you again in other episodes.
Okay, thank you as well for attending. Thank you for inviting me.
Thank you.
Thank you. And of course, just to remind everyone, at 4 o'clock, we'll be having our closing ceremony and also a wrap-up session. Right? So, again, thank you. Terima kasih kepada semua. Assalamualaikum warahmatullahi wabarakatuh. Bye. Thanks, Mia.
Thank you so much. Oh, Thank you, Mr. Volker. Thank you, Mr.
Bye. See you again.
Thank you.
Bye.
Thank you for hosting.
Looking
Thank
forward to work
you.
together. All right. Okay.
Bye.
Okay, bye, bye.
Bye. Okay, I stop. Recording?
Save event time.
Wait.
Wait, check.
Did record on?
Yeah.
Pause,
Okay.